All right. Good morning, boys and girls. How are we doing today?
Good morning.
Morning.
Morning. All right. So today, before we start our lesson, we're going to go over our classroom expectations again. All right. So our first one: be respectful. How does that look like? Being respectful in the classroom. Annette, what do you think?
Listening to you when you're talking.
Listening to the teacher, but who else?
Any other students that are talking.
Any classmates that are talking, make sure whoever's talking we're giving our undivided attention to, and we're listening, paying attention. And Joel, make sure we're paying attention right now. Joel, what's another way being respectful can look like?
When Annette's being annoying, don't throw things at her. Raise my hand and tell you.
Raise your hand if you want to speak, right? That's what we'll take away from that. Good. Our second rule: be engaged. What does that look like in the classroom?
When you are
Annette,
when you're participating, answering questions and listening to the teacher.
Good answer.
She didn't raise her hand.
Yes, she did raise her hand.
You had to tell her.
Maybe if you had your pencil down and were paying attention, you would have noticed that. All right. And third is always give your best effort. All right, let's try to keep it together now, class. All right. Always give your best effort, even if you get to school and you're tired, you had a long day. Just try and give your best effort and everything. Okay. Okay, so today we're going to continue our unit on Earth and the solar system. I know last week we talked a little bit about how relative distances from Earth affects apparent brightness of the sun compared to other stars. And so how close or how far we are from the sun versus how close or far we are from a star in a different galaxy or whatever will kind of depend on the brightness of the sun or the stars. So that's kind of what we talked about last week. This week today, and the next day or two, we're going to be talking about seasons. So, how many seasons do we have? Yes, Annette?
4.
4. Good job. Now, it's important to know we have 4, not 5, right? Because what's one of the seasons that has 2 different names?
Oh, that's fall
or
autumn.
Right, and those are the same season.
Yes.
Just because they can be called 2 different things doesn't make them 2 seasons, right? So we have 4 seasons. So what are the seasons? And that gave us fall. Joel, what are 1 or 2 of the other seasons? Or the rest, if you know them.
Oh, I know all of them, but she took the one I wanted to say. But after fall is winter.
That's good. What comes after winter?
Spring.
Yeah. Alright, and then what?
Summer.
Yeah, I'm sorry. My dad likes to be a jokester sometimes, so we're gonna try to keep ourselves composed during this lesson. Good, summer. So, if you start with summer, then you go to fall, then spring, fall, then winter, then spring, right? Those are 4 seasons. All right, so we're gonna do an activity right now, so you guys can use color pencils or markers here, or pencils. So what we're gonna do is you're gonna make like a little chart or something, and you're gonna write each season, summer, fall, winter, spring, and you're gonna draw 1 or 2 things that help that you think of whenever you think of that season. So give you about 5 minutes. 5 minutes here to do that.
My mom forgot to put my glasses in my backpack again. Can't see.
You forgot your glasses again?
No, my mom did.
Your mom forgot. Is that her responsibility to put your glasses in your backpack?
Well, yeah.
Yeah. Just do the best you can, okay? That's what you can see. It's good football. It's better than what I can draw. Have just a few more minutes here. These pictures are looking really good. Good work. About another minute or so here. Don't want to rush you guys, but take your time. Make them look pretty. They're looking good. Or manly. If you want your pictures to look manly. Instead of pretty. let's go ahead and finish up the picture you're drawing here in the next 30 seconds or so.
Finished.
Great job, Joel. That looks really, really good. All right, you can go ahead and hold on to it. We're going to talk about it here in a second. All right, so who would like to share first about the pictures? Annette, go ahead. Let's hear it.
Well, I put summer first, and I like summer because it's warm and sunny outside, and you get to go swimming, and I had put a beach ball there for swimming. And fall is football season, and it's also when the leaves fall off the trees. And then in wintertime, we get to celebrate Christmas and eat candy canes. And in the spring, that's when the grass and the flowers start to grow.
Awesome. Great job. So what season is your favorite and why?
I like fall,
Fall.
yeah, because I like eating s'mores.
S'mores. S'mores are really good. Do you heat them up in the microwave, or do you like to grill, put them on sticks and heat them in the fire?
I like them when you put the marshmallows on the fire.
On the fire, yeah. That's when they're the best. Awesome. Great job. Thank you for sharing. Joel, would you like to go next?
I did summer too, and first, but my pool actually has people in it.
Awesome.
That's a diving board, and that's a guy diving in the water,
That's really cool.
and that's a beach ball.
It looks like a baseball.
It's really big. And then for winter, I drew a Christmas tree because Christmas is in the winter, and I drew gifts under the tree because I like to get gifts. Oh, I skipped fall though. Fall goes
That's all right.
after summer.
Yep. Go
And
back
then
to it.
fall, I drew a football because fall's when football starts. And I drew
Yeah.
number 7 because that's the greatest quarterback ever, John Elway. And I drew a football field with the Bronco in the middle of it.
Awesome.
And then spring, I drew a house with a really nice yard because that's when people start doing yard work. And trees and bushes and the sun shining.
Number 7 is Coach Tim's number.
Yeah, you're right. That was my number when I was in college. Yeah. Back in the old days. All right, so I'll go ahead and share mine with you. For summer, I drew swim trunks and a beach ball because in summer I like to go swimming, and beach ball reminds me of the beach. And I don't get to go to the beach very often, but I like to go to the beach. It's fun. Fall, I drew football because I played football in college, as you all know, and so I love watching football on TV and playing football. And I drew some leaves because that's when the leaves start changing colors and they start falling off the trees. Winter, I drew a snowflake and a snowman just because it snows a lot in winter and you can build snowmen. I should have drawn like a Christmas tree or something because my birthday's on Christmas, but it wasn't one of the first things popped into my head. And in spring, I drew flowers because that's when all the snow starts melting away and the flowers start blooming and it gets real pretty outside. So those are my pictures. So now we're going to watch a video kind of talking about the seasons, and it explains the seasons a little bit more for you. So I hope you guys like this video.
Winter, spring, summer, fall. Seasons. I just love them all. Other than inspiring me to make up goofy poetry, why wouldn't you love the seasons? There's always something to look forward to. You already know that summer means long days of fun in the sun, and winter means shorter days, not to mention building snowmen and making lots of Frozen references. Okay, so clearly the sun and seasons are linked. But how? You already know that the sun is pretty important. It is the center of the solar system, after all. You also know that our planet, Earth, revolves around the sun, making its orbit once every 365 days. And remember, Earth isn't taking that lap while it's standing straight up and down. Instead, it's tilted on its axis, the invisible line around which our planet spins. Put together, the Earth's tilt on its axis and the orbit it makes around the sun, and you get the yearly pattern we call seasons. Let's see how. Since the Earth is tilted, for part of the year, one of the hemispheres, which is half of the Earth, is leaning toward the sun, and the other part of the year, it's leaning away. Let's follow the northern hemisphere once around the sun to see how this works. In June, the northern hemisphere is tilted towards the sun. This means that it's getting a lot of direct sunlight, light that's hitting it straight on. If you are sat directly underneath a bulb, you know that things can get pretty hot, and that's exactly what's happening to the northern hemisphere. It's summertime and the living is easy. Temperatures are warm and days are long. In December, though, the northern hemisphere is tilted away from the sun. It's getting indirect sunlight, meaning light is hitting it at an angle. Indirect sunlight means cooler temperatures, shorter days, and, for lots of folks, hot cocoa and bundling up since it's winter. But how can the angle of the sun's light make a difference between hot and cold? Well, try this little trick with a flashlight. Get a flashlight and dim the lights in your room a little bit. If you turn the flashlight on and point it straight down onto your desk, you'll see a small, bright, concentrated circle of light. That's kind of how sunlight hits the northern hemisphere during the summer. Bright and intense. Now move the flashlight down at an angle and point it at the top of your desk. See how the light isn't as bright and is less intense where it falls? That's like the sunlight we get in winter. But what about spring and autumn? During these two seasons, the Earth's orbit causes the northern hemisphere to be neither tilted toward the sun nor away from it. So temperatures during the spring and fall are more moderate, not too hot and not too cold, since the entire globe is getting about the same amount of direct sunlight at once. Now, let's take a look at how the amount of sunlight affects temperatures in the northern hemisphere over the course of a whole year. An easy way to show this yearly pattern is by using a graph. This graph shows the average high temperature each month for 1 year in Toronto, Canada, where I live. Looking at the graph, we see that during December, January, and February, when the northern hemisphere is getting very little direct sunlight, temperatures are low. And in the months of June, July, and August, when the tilt of the Earth on its axis is causing Toronto to get direct sunlight, the temperatures are much higher. Proof positive that something is going on here, and that something is this. The season that you're experiencing right this very minute is caused in part by the amount of direct sunlight you're getting. So, seasons are caused by the Earth's tilt on its axis as it cruises around the sun in its orbit. When one hemisphere gets more direct sunlight, it's summer there. Temperatures are warmer, days are longer, and nights are shorter. And when it gets more indirect sunlight, it's winter. Temperatures are cooler, days are shorter, and nights are longer. And now you know what causes summer, spring, autumn, and winter.
Alright, so what are some ways that you can tell differences between the seasons? What did you guys get from that video? Yes, Annette?
The temperature is different depending on where the tilt of the Earth is compared to the sun.
Mm-hmm.
So they're either hotter or colder or more normal.
Okay, good. That's a really good answer. Joel, what about you? Did you get anything from that?
The days are longer when it's summer,
Good.
and the nights are longer when it's winter.
Awesome. Great answers. So kind of talked about, and that you kind of touched on this, the hemispheres. So the north, really talked about the northern hemisphere mainly. So in the northern hemisphere, which is where we are at in the United States, when we're tilted toward the sun, that is when we're in summer, and our days are long. The sun rises up earlier in the day and sets later in the day, and so we get sunlight for a longer period of time throughout the day. So that's when we're tilted toward the sun, and as we rotate around, or as we orbit around the sun, the days start to get shorter, and we start to receive less direct sunlight. And so, because we're not getting the sun directly shine on us, the temperature starts to drop a little bit. And so, by the time winter comes around, the Earth, the northern hemisphere where we're at, is tilting away from the sun. So that's why the nights are longer, And the days are shorter and the temperatures get colder. And then by the time spring starts to come around, the days start getting longer again. The temperatures start getting a little bit warmer, but they can still be cold in the spring and the fall because we're not getting necessarily direct sunlight. And like I said, how long there's sunlight in a day is another way you can tell. So if the sun sets later and rises up earlier, you're probably in the summer, or you're in the early stages of fall or the late stages of spring. If it's darker outside longer, you're in winter or the late stages of fall or the early stages of spring. So now we're going to watch a video kind of talking more about the rotation of the Earth and its axis and those kind of things. Bring back in for you guys.
You've seen the sunset, right? And if you get up early enough, maybe you've seen it rise too. But have you ever wondered, if the sun rises every day and sets every night, where does it go when we can't see it? Well, nowhere. It's actually us that goes somewhere, because we're on the Earth and our planet is always turning or spinning on its axis. Imagine a line passing through the center of the Earth that goes both through the North Pole and the South Pole. We call that invisible line the axis. Earth spins around on this axis like a top. This spinning movement is called the Earth's rotation, and the Earth's rotation is what gives us day and night, every day, all year. If you're on the side of the Earth that's facing away from the sun as the Earth is spinning, it's night. If you're on the side facing the sun, it's, you guessed it, day. Now, hold on tight, because the Earth is actually moving in more ways than one. At the same time that the Earth spins on its axis, it also orbits or revolves around the sun. This movement is called its revolution. One full orbit all the way around the sun is one revolution, and the Earth takes 365 days, or 1 year, to complete a revolution. So have you got all of this so far? The Earth is rotating on its axis, creating day and night, and at the same time, it's revolving all the way around the sun. As the Earth is both rotating and revolving, it's not sitting straight up and down. Its axis is actually tilted, just a little. It's not all that much, but this tilt causes one part of the Earth to lean towards the sun, while another part of it is leaning away. This means that different parts of our planet's surface gets different amounts of sunlight and heat. So, why am I telling you all of this? Well, as the Earth travels around the sun, it creates a pattern throughout the year. This pattern happens over and over again, and I'm sure you've noticed it. At certain times of the year, you see the northern hemisphere leans towards the sun, and the southern hemisphere leans away. And at other times, the southern hemisphere leans towards the sun, and the northern hemisphere leans away. That pattern, my friend, is what makes seasons. When the part of the world that you're living in is leaning towards the sun, it's warm and the days are long. Summer. When you're on the part that's leaning away from the sun, it's cold and the days are short. Winter. In between, it's spring or autumn. If the Earth weren't tilted, we would have the same season all year long. So, revolution, rotation, orbit. Is your head spinning? Let's do a demonstration to shed a little light on these concepts. Okay, you're gonna need a globe and a table lamp without a shade, plus a table to put them both on. Put the lamp in the center of the table and turn it on. Put the globe on one side of the table. Now hit the lights. The globe is Earth. Makes sense, right? The lamp at the center of the table is the sun at the center of the solar system. Now slowly spin the globe. As the Earth rotates, the sun lights up one side of the planet better than the other. It's day where the light is shining more brightly on the globe and night where it's not. Now let's see what the Earth's revolution around the sun looks like. Give the globe a few spins with one hand while slowly pushing the globe in a circle around the sun, or the lamp, with your other hand. So, do you notice how the Earth keeps rotating as it revolves around the sun? If this were the real sun and Earth, by the time you get back to where you started, the globe would have completed 365 rotations or days. And that's another year gone by. So, what does all this show us? It shows that what looks to us to be the motion of the sun in the sky is really caused by the motion of the Earth. So now you know, when you look up and see the sun setting or rising, it's not going around us. It's sitting pretty much at the center of the solar system, while we and the 7 other planets go around it. That sun, always gotta be the center of attention.
Alright. So what was different about that video from the other video that we just watched?
It It showed a different way the Earth moved.
Yeah, focused more on how the Earth moves and its orbit and things like that, right? Yeah. So after watching this video versus the other one, what are some of the causes that cause the seasons to change? Like the last video, we learned about the seasons, but why? This video, we kind of learned more why they change. So why? What do we get from that?
It's because of the Earth being tilted
Mm-hmm. The Earth is tilted on its what? Do you remember?
on its axis.
Its axis, right? Yeah.
So that when it spins, as it goes around the Earth, that's what causes the seasons, is where you're at in relation to the sun.
Yeah, good. Really good. Yeah. Alright, let's make sure that all our pencils and everything are down right now. Thank you. Joel, what did you get from this video? What causes the seasons to change?
It just depends on where the Earth is around the sun.
Good. Good. Perfect. Exactly what we were looking for. So a few things that we learned in that video about the Earth. Joel, let's go ahead and make sure we put our pencils on, okay? Please, thank you. So, orbit. So what was, did anyone catch what orbit was in the video?
Orbit is the Earth going all the way around the sun.
Perfect. Good job. So, how long does it take for the Earth to get around the sun one time? Joel?
365 days.
365 days. And what about on a leap year, do you know? Joel?
366 days. 364 days.
There you go. Great answer. Alright, so revolution. What's a revolution with the Earth?
It's
When it goes all the way in a circle.
Yep, so revolution is one full orbit, right? Orbit is when the Earth is orbiting around the sun. When the Earth gets to the same point that it started at, that's called a revolution. It had one full orbit. Rotation. So what rotates?
the Earth.
The Earth. The Earth rotates. It spins on its what? And
Its
that
axis.
its axis. And what is the axis?
It's the center.
It's the center invisible tilted line, right? That's what the Earth.
From the North Pole to the South Pole.
Yes, great job. And what the Earth rotates around, correct? Awesome. Alright, so now we're going to do another activity here. You get to use your markers again.
I don't have markers, I have color pencils.
Yeah, color pencils, that'll work too. So now is when you can get to pick up your pencils or your markers and draw or doodle. So you guys can just go ahead and do it on the back of the first page that you used. So what I want you guys to do is I want you to draw a diagram of Earth's rotation around the sun. I want you to be detailed with it, okay? So make sure you draw the Earth in its 4 positions with the seasons and label the seasons and draw the axis and everything like that. And just give a representation of how the Earth rotates or orbits the sun. You guys about 3-4 minutes here to do that. 5 minutes if you need an extra minute. Bless
Excuse me.
you. Alright, how we doing here? Doing good? It looks good so far.
That's what football season is. Isn't that winter? Winter would be. Here, I will write my S's. S. F.
Is that right?
Yeah, that's really good. Now go ahead and shade in the parts that would not be getting any sun, like the northern hemisphere would not be getting any sunlight.
Like the northern hemisphere part.
From where we are, yes. So shade in the part that would not be getting sunlight. There you go. Or wouldn't be getting as much sunlight, I should say. That's great. Alright, awesome. We done? Everyone done?
I guess.
Alright. So here, I'll kind of give you an idea of what this looks like here. So we start out with summer. The northern hemisphere is tilted towards the sun, correct? So that means that this part of the earth is going to be getting the most sunlight. And then the shaded part over here, my blue means is like representing the earth, like the water. And so that's what's getting the most sunlight. So for the summer, the back part is what's not getting as much sunlight. Fall is here. Winter is here. The northern hemisphere is tilted away, so they're not getting as much sunlight. And spring is here. And so fall and spring, they're kind of the moderate ones. Like they kind of get moderate temperatures, not too hot, not too cold, things like that. So it looking at you, it looks like you guys did a good job. It was a really good job. Nice job. So here, before we get to leave today in this unit, we're gonna take a little quiz, an exit slip, so you guys can go ahead and hand in your drawings that you did today for points. Thank you. Thank you, Joel. You guys did a nice job.
I didn't put my name on.
Oh, here, let's make sure we put our names on them. Awesome. Thank you, Annette. Thank you, Joel. Alright. And you go ahead and take out that other piece of paper you got. And we're going to take a little quiz here. More questions, okay? Make sure to write our names at the top, so I know who to give points to. Alright, so question number 1. What is it called when the Earth travels completely around the sun? And how long does it take? What is it called when the Earth travels completely around the sun? And how long does it take? Alright, everyone ready for the next question?
Yes.
Alright, question number 2. Is the Earth's axis straight up and down or tilted? Straight up and down or tilted? The Earth's axis. Good job, everyone ready? Number 3. Alright, when the northern hemisphere is facing towards the sun, what season is it? And when it faces away from the sun, what season is it? And then when it's neither facing towards the sun or away from the sun, what seasons could those be? So you have 3 different parts to this question here. Everyone ready?
Earth went one full revolution waiting on her to get her answer done.
Alright, let's let's make sure we keep our comments to ourselves, okay?
I'm sorry.
Thank you. We apologize to Annette.
Sorry.
Thank you. Alright, last question here. So it's going to be matching. Let me do it. Alright, so we're going to be matching the words to their definitions. So your words are going to be orbit, revolution, rotation, and axis. You guys go ahead and write those 4 down, and then I'll give you the options. Orbit, revolution, rotation, and axis. So the first definition is what the Earth spins on. Write that next to which word you think it is, or which word you think it matches with. What the Earth spins on, or what the Earth rotates on. Alright, remember the next one? This is when the Earth spins on its axis. This is when the Earth spins on its axis. All right. Next one. The Earth moves around the sun. The Earth moves around the sun.
Done.
Great job. Remember, we're taking a quiz though, so let's be quiet, okay?
Sorry.
It's all right. Thank you. All right, last one. One full orbit around the sun. One full orbit around the sun.
What was that one again?
One full orbit around the sun. Great job. And then whenever you're done, you can go ahead and turn them in. Make sure names are at the top. Joel, can you please write your actual name? Alright. Thank you.
You're welcome.
Please write your actual name on your paper, Joel, or else you're not going to get any credit for it. Or else will take 0 on this quiz. In case you guys want to know what he wrote stud muffin. Then he wrote, she's angry.
She's annoying.
Annoying. Looks like angry. And then he wrote dad instead of his actual name. So, thanks for tuning in.